This video is looking at the steps involved in testing a claim about a proportion using the formal hypothesis test or the p-value method. So it's pretty much the same as the methods for testing the claim about means. The formulas for the test statistic, though, are different because we are looking at proportions and not a means. So for the proportions test, it's based on the fact that our normal distribution approximates the binomial distribution. So again, we're using P and Q from our binomial distribution. So our steps, same as earlier with our hypothesis testing. Identify the claim, write it in symbolic form. Using the symbolic form, state the null and alternate hypotheses. Decide on alpha. Determine both the test statistic and one other thing, so either the critical values or the p-value. So this is an either or, you don't need to do both. The decision step depends on which you did in 4. So if you calculated the critical values, then you're rejecting the null hypothesis if the test statistic is in the critical region. If you chose instead to go the route of the p-values, you are rejecting the null hypothesis if the p-value is less than the significance level. And lastly, don't forget to write a statement addressing the claim or the question. So first example here, as usual, we're looking for what the claim is. And as usual, we've got this nice test the claim, and what follows is the claim. So the percentage of job seekers is higher for Alberta. So we're comparing this to the national of 16%. So higher would be greater than, which does not involve inequality, so we're looking at an alternate hypothesis. So the null hypothesis, we're testing against the equality. If you want to show it as exactly the opposite of the claim, less than or equal to. Either way, we're looking at the claim is greater than, so it's going to be right-tailed. Remember to identify everything you can in the question. So we've got our proportion, and we need n is 550. Our proportion of our sample is going to have to be calculated, right? So we have the 105 divided by our 550, and alpha is given in the question. So we can use those values to calculate our z-score. Remember that the p hat is our sample one, and our p is the one from the population, or in this case from the claim, because it's a claim about the population. So when we plug that in, we can do our calculation. I encourage you to take a moment to try the calculation, make sure you can get the same answer. And we get 1.98. So that's our test statistic. Then we have two choices. We can either figure out the critical value from our alpha, or we can figure out the p-value from our test statistic. So if you're looking for the critical value, well, our alpha is 0.05. So on our diagram, we're going to have this is 0.05. We're looking at a right-tailed test, so we'll look up 0.95 on our z-score table. And we find that it is 1.645. So if we're looking for the critical value, that's what we do. And that's our value right there. And remember, we're comparing that to our test statistic, which 1.98 would be over here. Our other option is to take our test statistic and calculate the p-value for that. So that would be a matter of looking up 1.98 in our table, on the t-table. So 1.98 is going to be here. And then don't forget that gives us the area to the left, and we want the area to the right, so we subtract to get our actual answer. And so our p-value, if you choose to do it that way instead, works out to 0.0239. Either way, we're comparing the p-value to alpha, which we would say the p-value is less than alpha, or we're looking to see if our test statistic falls in the critical region, which we also say the test statistic falls in the critical region. So whichever one you choose, we end up saying, oh, we reject the null hypothesis. So if we're rejecting the null hypothesis, we're supporting the claim. And remember, we can do that through our flowchart as well. Right, so our claim did not contain the condition of equality, so we said no. Do we reject the claim? We just said yes. So our final statement should say there is enough evidence to support the claim. Don't forget to restate what the claim is about so that someone could read this. Ultimately, your final conclusion, someone should be able to read it, not know a thing about statistics, and that statement should make sense. Right, and should address the question that was asked. So that's that one. Second example. So we've got a study and a researcher is concluding that they think the figure is higher for oil and gas companies. So they select several companies and again find a proportion. Identify our claim. So does the test show, and then we see what our claim is. A significantly higher proportion have health and productivity. So it's a higher proportion than the one in the study, 67%. So we calculate that. And we're looking at greater than again. So this is another one that ends up being a right-tailed test. Our null hypothesis, if we're writing it as directly opposite is less than or equal to, remember, we're always testing against that equality. Identify our variables. So n is 450, alpha is 1%, x, so we can calculate our proportion, is 297, and then for our proportion out of that 415. From there, we can calculate our test statistic. Again, be careful which one is the p hat and which one is p. Coincidentally, this one also works out to 1.98. Different alpha though, so not necessarily going to have the exact same conclusion. So either calculate our critical value from the alpha. So if we're looking at that, this would be 0.01 this time. So we look up 0.99 and we find that Z is 2.33. Remember, you can also do these on Excel as well as with the table. And let's label that as critical value so we can differentiate from our test statistic. So our test statistic, 1.98, is going to fall somewhere around here. So this time our test statistic is not in the critical region. Likewise, we could calculate our p-value. So if we look up 1.98, the p-value is actually the same as last time around because our test statistic happens to be the same. So 1 minus 0.9761, because that's the value we get out of our table. We get 0.0239. P-value is not less than the significance level. So both of those things are nots. It tells us we do not reject the null hypothesis. So we're not rejecting this, means we're not supporting the claim. And again, let's look at that flowchart just quickly. Right, does the claim contain equality? No. Do we reject the null hypothesis? No again. So there's not enough evidence. Specifically in this case, not enough evidence to support the claim that a significantly higher portion have health and productivity plans. So pretty similar to our other hypothesis tests, but we've got this new formula that we have to work out.